Okay, let's try an example using this new arbitrary domain version of the Fourier series. Okay, first you have to calculate A0. A0 according to this formula is 1 over, what's our L in for this question? 3, right?
3.
So it's 1 over 3 from -3 to 3 of absolute value of x times cosine 0 is?
And x.
Cosine 0 is?
Okay.
1. Okay. dx. Cosine 0 is 1. So if you plug, we're doing a of 0. So n is set to 0, so we're setting n to 0. Right, and then absolute value of x is either even or odd?
Even.
Even. So you can double the domain and integrate from 0 to 3, absolute value of x dx. But then, what is absolute value of x same as when x is from 0 to 3?
Just x.
Yeah, it's just x because x is always positive on this number, right? So we have that.
It's even because it's like this, right? The graph.
Yeah, it's even because the graph goes like this, right? The left and right matches.
Symmetrical?
Yeah, symmetrical. Okay, now you integrate this. It's 1 half x squared. 3 and 0 is plugged in. 2/3. And when you plug in 3, that's 9 over 2. So it's 2 over 3 times 9 over 2. 2 cancels. 9 over 3 is 3. So you get 3 as A0. Okay, now let's try AN. 1 over 3, -3 to 3, absolute value of x, cosine n pi x over L, where L is 3. That's what you have to compute. I'm putting here L as 3, and that's the integral I have to compute. That's even times even is even, so what do? Double 0 to 3 integrate x times cosine n pi x over 3 dx. Now I got rid of the absolute value because now the domain is from 0 to 3, so absolute value of x is same as x on this domain. And then here now you have to use either the tabular integration or integration by parts. And since I feel we did enough, let's just do this. I'll just do this in my head. So you integrate cosine, it becomes sine, so it's 3 over n pi x times sine n pi over 3x. And that's what you get if you integrate the second one. If you integrate this, the reciprocal of the coefficient n pi over 3 comes in front. Okay? This is the reciprocal of this. And then you have to do minus of, with this being, well, let's do it. 3 over n pi. The integrate by parts says you differentiate the one that you didn't integrate. So if you differentiate x, you get 1. So now you have to integrate. And then from 0 to 3, which gives you sine integrates to negative cosine, so you're going to get another of these 9 over n squared pi squared cosine n pi over 3x. And then that's it, right? Okay, I'll have to erase this. I didn't want to erase it. I guess I'll have to erase it. Okay, so in the next line, it's 2/3 3 over n pi x sine n pi over 3x plus 9 over n squared pi squared cosine n pi over 3x. And then you have to plug in what and what?
0 and 3.
3 and 0. Is there something that I did wrong?
No, sorry.
Okay. All right. Now, when you plug in 3 here, 3 cancels and you get sine n pi. What's that? What's sine n pi? 0, right? When you plug in 3 here, you get cosine n pi. What's that?
Negative 1.
Negative 1 to the nth power. Right? It's 2/3 9 over n squared pi squared negative 1 to the nth power. So that's what you get when you plug in 3. When you plug in 0 here, what do you get?
0.
0. 0 here, what do you get? What's cosine 0?
1.
1. So you have to subtract 9 over n squared pi squared times 1. Because you plug this in, plug that in, you have to subtract the 2. Okay. All right. Now we multiply 2/3 to it. So 9 over 3 is 3. 3 times 2 is 6. So you have 6 over n squared pi squared for both of them. But let's factor these out. I think that's better. So I get negative 1 to the n minus 1. So that's your AN. How about BN? BN is 1/3 negative 3 to 3 of absolute value of x sine n pi x over 3 dx. What's that? Why? Why is it 0?
It's even and odd.
Because this is odd, that's even. Even times odd is odd. If you integrate odd function over a symmetric domain, it's equal to 0. Good. Now we have all the A0, AN, BNs. Therefore, we can rewrite absolute value of x as 3 over 2 plus sigma n from 1 through infinity of that thing 6 over n squared pi squared negative 1 to the nth power minus 1 cosine n pi x over 3, and there's no sine term because all the bn's are 0. Now remember, in the formula, it's a0 over 2 plus sigma an cosine n pi x over L. So that's where this 2 comes from. 2 comes from the formula. Even though a0 is 3, you have to divide by 2. And the remark I was making about this, whether to divide by 2 or not, if you don't put this 2 in the formula, then when you calculate, you have to divide by 2 instead. So that increases the number of formulas that you have to remember for the AN. So people like to put the 2 here. But that's optional. Some do it the opposite. Any questions?